Our Earth is often called the blue planet, that's because most of its surface is covered by water. The oceans, they're truly enormous and incredibly deep too. Just imagine the tallest mountain on land, Mount Everest. If you could place it in the deepest part of the ocean, its peak would still be submerged more than a mile underwater. This deepest point is known as the Challenger Deep, a place of profound mystery. This deep ocean remains one of the last great unknown frontiers. It's a vast, dark and silent world. We currently have more detailed maps of the moon's surface and even better maps of Mars than we do of our own planet's seabed. This hidden realm covers nearly 3/4 of Earth, yet so much of it remains completely unexplored. It's a kingdom of secrets, waiting patiently beneath the waves, a place of wonder and immense scale. Humans have always been driven by a spirit of exploration, haven't we? We've climbed the highest peaks, ventured into the most remote jungles, and even set foot upon the moon so far away, but reaching the very bottom of our own oceans? Well, that presents an entirely different kind of challenge. Only a tiny handful of brave individuals have ever descended to these extraordinary, crushing and alien depths. The journey is perilous and the destination hostile. So why is this vast domain so incredibly difficult to reach? Why can't we just dive down or send our machines with ease? The reasons are numerous and complex. The ocean fiercely guards its deepest secrets. Its abyssal plains and trenches present extreme physical obstacles, conditions unlike anything found on dry land or even in the cold vacuum of outer space. Let's now journey into understanding these formidable challenges. Imagine a world where the sun's rays can never penetrate. That's the reality of the deep ocean. Sunlight, the source of so much life on Earth, only reaches a few hundred meters down. Below this sunlit zone, there's only endless perpetual night, an inky blackness that stretches for miles. No plants can grow in this eternal darkness. The process of photosynthesis is entirely impossible here. It's a truly alien environment, profoundly different from our familiar sun-drenched world above. It's also an incredibly cold place. Far from the sun's warmth, the water temperature in these depths hovers near freezing point, typically just a few degrees above 0 Celsius. This constant, biting chill makes survival extremely difficult for any form of life that dares to exist there. And it poses a great challenge for any instruments or vehicles we send down. They must be built to withstand this severe, relentless cold, especially during long periods of deep-sea exploration and study. However, the most significant challenge of all is the immense pressure. This is the colossal weight of all the water above, pushing down with unimaginable force from every direction. At the surface of the ocean, we experience one atmosphere of pressure. But as you descend, this pressure increases dramatically. For every 10 meters you go down, the pressure increases by another atmosphere. Imagine an elephant standing on the area of a postage stamp. Now imagine hundreds, even thousands of elephants. That's the kind of crushing force present. This overwhelming pressure is truly destructive. It would instantly crush a conventional submarine or, tragically, an unprotected human body. The force squeezes everything with an iron grip. Materials that are strong on land behave very differently under such stress. Even the most robust metals can buckle, bend, or implode. This immense, unyielding pressure is a primary reason why the deep abyss remains so profoundly unreachable for us, and why exploration requires such extraordinary engineering. To explore these dark, cold and crushing depths, we need very special tools. Humans, in their natural form, simply cannot survive there. So we've designed and built incredibly strong submersibles. These are like small personal submarines, but much tougher. They possess exceptionally thick hulls, often made of titanium. These strong walls are engineered to resist the immense pressure, creating a tiny, safe bubble, protecting the explorers within their cramped cabin. These deep-sea submersibles are true marvels of modern engineering, yet they still have significant limitations. They're typically very small and can only carry 2 or 3 people. Their power supplies, usually batteries, are finite, meaning their missions can only last for a limited number of hours. Communicating with the support ship on the surface is also very difficult. Radio waves, which we rely on in the air, don't travel well through dense water. Acoustic modems are used, but they're slow. We also deploy robotic explorers to venture into the abyss. These are commonly known as ROVs, or remotely operated vehicles. ROVs have no people on board. Instead, skilled pilots control them from a ship on the surface. They're connected by a long, strong tether or cable. This cable provides power and transmits data and images. These robots can stay submerged for much longer than manned submersibles, and they can be sent to more hazardous locations. But they too face their own set of operational challenges. The deep ocean floor is an enormous uncharted territory. Mapping its features is a painstakingly slow and methodical process. Navigating accurately in total darkness is extremely tricky, even with advanced sonar systems and powerful lights. Constructing these sophisticated deep-sea vehicles is incredibly expensive. Each mission is complex, requiring a large support team and ship. And if something goes critically wrong in those remote depths, rescue is, for all practical purposes, almost impossible. Technology is constantly being pushed to its very limits. Despite all the dangers and the immense difficulties, we continue to explore. We're driven by an insatiable curiosity because the deep ocean is an endlessly fascinating and mysterious realm. It's believed to be teeming with countless unknown species, wonderful creatures uniquely adapted to survive the extreme conditions, life that can thrive in the total absence of sunlight, often using chemical energy from the Earth's interior. This process is called chemosynthesis, and its discovery fundamentally changed our understanding of biology. Recent scientific expeditions are constantly revealing more wonders. New types of hydrothermal vents are being discovered regularly. These vents are like underwater hot springs, gushing superheated, mineral-rich water. They support vibrant and unique ecosystems in the surrounding cold, dark sea. We see bizarre fish with their own glowing lures, giant tube worms, some several meters long with no mouths or stomachs. Each dive, each sample can bring astonishing new insights, a testament to the incredible tenacity and diversity of life on our planet. Understanding the deep ocean is not just about curiosity, it's of vital importance for our entire planet. This hidden world plays a crucial role in regulating global systems. It influences our climate and intricate weather patterns. It may hold vast, as yet untapped, natural resources, but it also contains incredibly delicate and ancient ecosystems. We must learn as much as we can before we consider disturbing them. Responsible and careful exploration is absolutely key for the long-term health and balance of our world. The ocean's profound depths remain largely unknown to us, a final, vast frontier still present here on our Earth. But our innate human desire to explore and understand drives us ever onward. New materials and innovative technologies are continually being developed. We aim to build vehicles that can go deeper, stay for longer periods, and see much more. What incredible discoveries, what new forms of life await us in those silent, dark, and seemingly unreachable places. The grand quest to know, to understand, certainly continues.